Hi everyone, this is a recap for remediation block so that we can go over some things that we've been talking about in Algebra 2, get you some extra practice, and also hopefully clear up any questions you might have had if you were absent during any of these topics. I am going to ask that you put all of this on notebook paper, make sure your name's on it, and then turn it in to me so that you can get credit for this. So, starting out, we're going to go back to the beginning where we have properties. And a lot of us just need to keep reviewing those properties so that way they're fresh in your mind, and in case you see one on the SOL, you can easily identify it and get it right. So the commonly missed properties that I saw on the Unit 1 test were things that looked like this. Now this one's set up to, it looks like you're going to do the distributive property, but actually they didn't do the multiplication. So for this one, what you want to notice is that the B and the C changed places. So this is, and over here, so this is the commutative property. And that's for addition. Another one that I noticed that was commonly missed was this one. So let's say we had this: if m equals 12, then 12 equals m. Now this looks like the commutative property, but this is actually the symmetric property. The last one of properties that I noticed that we need to work on a little bit is something that would look like this. This one, some people said was the identity property for multiplication because they saw that 1 right there. But actually, since we're multiplying by the reciprocal, this is the multiplicative inverse. Okay, so I'm going to give you some practice problems to do, and I want you to write them down on your paper, and then if you need to pause this video to look over your properties for a minute, or even better, if you have your notebook open next to you while you're watching this video, feel free to pause if you need to write things down. Here are the practice problems. So you want to write the property for each one of these. Okay, so take a minute or two, pause this video and try 1 through 5, and then we're going to move on to the next topic. Okay, hopefully you finished those 5 problems, and now we're going to go on to another topic that I wanted to go over, and that is absolute value inequalities. So when we're solving absolute value inequalities, this is the kind where we've got greater than and less than, or maybe we have greater than or equal to, or less than or equal to. And we're doing a really good job solving them, but sometimes we make a little bit of a mistake when we're graphing them on the number line. So that's really what I want to go over, and I really want to go over interval notation for this. So let's do an example. Let's say you have 5 plus 2 times the absolute value of x minus 1. And let's make that less than or equal to, how about 11. Okay? So the first thing that we want to do is subtract 5. Do not add the 5 and the 2. Remember, this 2 is connected to this absolute value. So you want to subtract 5 from both sides. And then you're going to bring down the 2 and then times the absolute value of x minus 1. And that's less than or equal to 6. Now, some of you like to distribute, some of you like to divide. At this point, you can do either one and be just fine. I think since 2 goes into 6, I'm just going to divide. So divide by 2 on both sides. That goes. So we have the absolute value of x minus 1 is less than or equal to 3. Now, from this point, we're going to make 2 equations. Remember, for absolute value, you need to make 2 equations. So the first one is x minus 1 is less than or equal to 3. The other equation is going to be x minus 1, again, is greater than or equal to negative 3. Don't forget to flip that second sign. So when we get, I'm going to separate this. So when we get the x by itself, we're going to add 1 to both sides. So x is less than or equal to 4. And then over here, we're going to add 1 to both sides and get x is greater than or equal to negative 2. So everybody does a great job with this. Now we just want to talk about the graphing. So when you graph the solutions to this, you make a number line, and then I'm going to put 0 on the number line, and then we're going to go and put a negative 2 right here, and we're going to put positive 4 right here. Now, since these are greater than and less than or equal to, look at the extra line there, we're putting closed circles on this. So closed circle on negative 2 and a closed circle on 4. Now, less than 4 is going to go this way, and greater than or equal to negative 2 is going to go this way. So your solution for this is where they overlap. So that's from here to here. Okay? Now, what you want to do is write an interval for that solution. So they don't overlap over here or over here. So we only want to look at from negative 2 to 4. And when you write your interval notation, you always go left to right. Has to go that way. Smallest to biggest. So left to right. So we have to ask ourselves, how far does our interval notation go to the left? Well, it goes to negative 2, comma, how far does it go to the right? It goes to 4. And then since these are closed circles, instead of putting parentheses around these, we're going to put brackets. So a bracket around negative 2 and a bracket around 4. That's the interval notation for this graph. Okay, so let's try another one. Here's another example. Let's say that you have, how about 7 minus 3 times the absolute value of 2x, and that is greater than or equal to, how about 10? Okay? So we're going to do the same thing here. We need to take care of the 7 first. Now this, when I noticed on the test, this is not a negative 7. This is a positive 7. The sign that's in front of the number is what goes with the number. So like the negative is in front of the 3. So that's a negative 3. There's nothing in front of the 7, so that's a positive 7. So we're going to subtract 7 from both sides. Okay? So then we bring down a negative 3 times the absolute value of 2x, and that's greater than 10 minus 7, which is positive 3. Okay, so at this point, I'm going to divide by negative 3. You could multiply these if you want to. I'm just going to divide. Either one is fine. But look, I'm dividing by a negative number. So when you're dividing by a negative number, you have to flip the sign. every time you divide by a negative number, you have to flip the sign. Okay? Only when you divide by a negative. So this is still 2x. This gets flipped to less than or equal to, and 3 divided by negative 3 is negative 1. Now I make my two equations. One equation is 2x less than or equal to negative 1. The other equation is 2x is greater than or equal to positive 1. So I had to flip it again. This is like one of those you got to double flip here. We flipped it for this, and then we flip it again for the second equation. All right, now we're going to divide by 2 on both sides. I'm dividing by a positive 2, so I don't have to flip for this. So x is less than or equal to negative 1/2. And then I'm going to divide by 2 on the other side and get x is greater than or equal to positive 1/2. So let's look at the graph for this one. Here's your graph. You got your number line. So we're going to put 0 on there. We need a negative 1/2 and we need a positive 1/2. Now, since these are greater than or equal to and less than or equal to, we're going to put closed circles again. We need to think what these mean this time. So less than or equal to negative 1/2. Numbers that are less than always shade to the left. Okay? And then greater than or equal to 1/2. The numbers greater than 1/2 are over here. That goes to the right. So this graph looks like this. They don't overlap in this example. So to do your interval notation, you'll need to do an interval for this, and you'll need to do an interval for this one. Two different intervals. This is the kind where you hook them together with the big U at the end. So we always go left to right. Okay? Always left to right, just like you read left to right. So this one's the farthest to the left, so we're going to do this one first. We're going to cover this one up, and we're not going to look at it. So how far does this go to the left? Well, if you go to the left forever, that's negative infinity. So we go negative infinity up to, how far do we go to the right for just this piece? We go right up to negative 1/2. It goes right up to your circle. Since it's a closed circle, we put a bracket around it. Now for this piece over here, how far do we go to the left? Right up to 1/2. Comma, how far do we go to the right? Well, if we go to the right forever, that's really positive infinity. So we put positive infinity. This gets a bracket because there's a closed circle there. This gets a parenthesis because it goes to infinity. We can't actually get to infinity, so we put a parenthesis there. And then you join them with a big U. That stands for the union symbol. Okay? So I would like you to try 3 of these practice problems on your notebook paper. So this would be number 6 on your notebook paper. Let's try this one. About 4 plus the absolute value of x minus 1, and that is less than 10. Number 7, let's try 2 plus 8 times the absolute value of 2x, and that's greater than or equal to 12. And then number 8, I would like you to try 5 minus 4 times the absolute value of x plus 3. And let's make that one be less than or equal to, how about 16? Okay? So you might have some fraction answers for this. Don't worry about that. You can always use your calculator. See what you can do with these problems. And then for each one of these, also graph them and do interval notation. Okay, so you're going to do just like I did for the examples above. Go ahead and pause the video and try these practice problems. Okay, so after you finish those, I want to go on to the last part of this, and this is graphing absolute value functions. Definitely want to go over this one so that way if you were absent or if you're still a little unsure about this, you get another chance at seeing some examples. So the general form, well, first of all, the parent function for all absolute value functions, the parent function is like the original function of all absolute value functions, is y equals the absolute value of x. Okay, so you want to remember that. Your general function that helps us figure out how it moves, and another way, a mathematical word for how a function moves is called a transformation. So when you see the word transformation on your test, I'm just asking you to tell me how it moved. So your general function is y equals a times absolute value of x plus or minus h plus or minus k. Okay, so before we actually graph, I'm just going to give you some examples and talk about how they move, talk about the transformations. Remember, inside the absolute value is your left or right movement. Outside the absolute value, that's your up or down movement. And then A represents whether you're going to have a face up V shape, a face down V shape, or a stretch or a shrink. If A is bigger than 1, it's going to be a stretch. Remember, that controls your slope. If A is a fraction between 1 and 0, that's going to be a shrink. Okay, so here's an example. You have y equals the absolute value of x plus 2 minus 5. So, since this is plus 2, if it's x plus 2 on the inside, it does the opposite movement of what we would actually think it would do. And this is going to shift to the left 2 units. The minus 5, since this is negative, this actually does what makes sense. This is going to shift down 5 units. And then out in front here, it looks like there's nothing there, but there's really a 1 right there. So that's a positive 1. Your slope will be 1, and this is going to be a face-up graph. Okay? These 3 little phrases that I just wrote down, those are called transformations. Okay? These are the transformations. So when you see the word transformations, that's what I'm talking about. Telling me in words how this moved. So if I do a sketch, and I know you don't have graph paper, and that's okay, we can do this on notebook paper, it'll still look good. We'll just do a sketch. We're going to start at the origin, go to the left 2, 1, 2, and then down 5, 1, 2, 3, 4, 5, and we're going to put a dot right there. And then it's going to be a face-up graph, and we're just going to kind of eyeball this, up 1 over 1, up 1 over 1, and so forth. So your graph will look like that. Okay, so your domain for all of these is going to be from negative infinity to positive infinity. Your domain is how far your graph goes to the left and how far it goes to the right, just like those number lines that we just did. This is going to keep getting wider and wider and wider as you go to the left and to the right. So it's going to go to negative infinity and positive infinity because it's just going to keep getting wider and wider. Your range is how low the function goes to how high the function goes. So when I'm doing a range, I put my pencil right on the y-axis and I follow down the y-axis until my pencil is lined up with about as far down as the vertex is. So I'm right in line right here. It looks like I'm down 1, 2, 3, 4, 5. So my range is going to be 5, comma. Now, how far up will this go? Well, there's arrows on the ends of this. So this is going to go way up to positive infinity. So the height is positive infinity. Since we can put our pencil on the, oh, that's a negative 5. Since we can put our pencil on the negative 5, we put a bracket around it. And infinity gets a parentheses. That's your range. Now at this point, I don't have graph paper, so I don't know exactly where we cross on the x-axis. But if I just circle those 2 spots, that's going to remind me of another part on this graph, and that's the solutions. The solutions are where the graph touches or crosses the x-axis. Okay? So you've got an example of how this works. I want you to try 3 practice problems for graphing absolute value functions. I want you to tell me the transformations, and then also do a sketch for me. Tell me the domain, tell me the range, and then circle the solutions on your sketch. If they even touch, if your graph even touches the x-axis. If it doesn't touch the x-axis, then you have no solutions. So try this one. Y equals the absolute value of x minus 1 minus 6. Go ahead and graph that one. I want to know transformations. Tell me how it moves. Then after you graph it, I want to know the domain and the range, and then circle the solutions. If you need to go back and watch me graph the other absolute value function, you can, to help you out with doing your graph. Also, have your notes next to you. That's going to help as well. Okay, here's the other one I would like you to try. Try y equals, oops, losing my paper, 2 times the absolute value of x plus 4, and then let's make this one be plus 3. So that way numbers aren't too big, you don't have to worry about making a big graph for this one. Now I am going to give you a little hint here. You got a 2 right there in front, so that means you're going to have a slope of 2 when you make your V shape. So that means you're going to go up 2 and over 1. Okay? For this second example, do transformations. Tell me how it moved in words. Make a graph. Then tell me the domain. Tell me the range. And then circle your solutions. When you're done with this review and you have everything written down and your name on it, turn your notebook paper into the white bin over on the bookshelf. Thanks a lot. I hope this helped.